Hey there, everybody. Welcome back. We're going to look at some examples of transformations. This is 14.7 in Calc 3. Let's just jump into it. Let's find the image of the square where the square goes from 0 to 1 in the u direction and 0 to 1 in the v direction. And we're going to do a transformation where x equals u squared minus v squared and y equals 2uv. So I've got my square set up here. I've labeled my vertices and my sides. I like to follow the path going around the shape for when I do the mapping, as you'll see in a second. So let's just start going along. If we look at side 1, how does that map? Along side 1, b equals 0. So x is now u squared and y is 0. And when we u goes from 0 to 1 there, when we stick in u equals 0, we get 0. And when we stick in u equals 1, we get 1. So x maps, we had 0, 0. It maps over to 0, 0, and 1, 0. So that looks like pretty much the same as it is right now. Let's take a look at our second side. Alongside 2, u equals 1. So we've got x equals 1 minus v squared and y equals 2v. And so if I want to get this in terms of x, y, v equals 1/2 y, and I stick that into x equals 1 minus v squared, we get x equals 1 minus 1/4 y squared, which is a parabola opening up to the left. If we check out the vertices, our endpoints along that side, if I stick in, we had 1, 0 and 1, 1. So what's changing here is the v value. We try v equals 0, and I get x equals 1. So we've got 1, 0, because along this side, y is, I'm sticking in v equals 0. So 0. And when I stick in v equals 1, I've got 1 minus 1 squared is 0, and 2 times 1 is 2. So this will map to 0, 2. And I'll show you the mapping in a second. I probably should have done this live, but didn't. Side 3 along the top, b equals 1. So when we plug that into u squared minus v squared, we get x equals u squared minus 1, and we get y equals 2u, which means u equals 1/2 y. We can get an equation for x. X equals 1/4 y squared minus 1 is a parabola opening to the right. And when we had b equals 1 along the top, we've got endpoints of u equals 0, u equals 1. Since I'm following the curve and I'm going this way, I'm going to start here and go over there. So when u equals 1, I plug it in. I've got x equals 1 squared minus 1 is 0. And y equals 2 times 1 is 2. So 0, 2. And when I stick in u equals 0, zero minus 1 is -1, and 2 times 0 is 0. So -1 and 0. This is all convenient. This is kind of nice because these points are matching up. So it is a connected region still. And when I do the final side, the left side where u equals 0, I just have x equals -b squared and y equals 0. So both endpoints have a 0 for the y component. We stick in our v values 1 and 0. If I stick in 1, I get x equals -1, which is good. This point connects to that point. And when I stick in v equals 0, I get x equals 0, which is good because it brings us back around all the way up to what we had up here. So we do have a nice connected region. And let's take a look at it. I had this here. That's just, I should have gotten rid of it. We started at 0, 0, and we went to 1, 0. If we look at it as a parabola opening to the left, and we're going from here to here, it's going to curve nicely like that. So that'll be our C. And R3 corresponds to side 3. It's getting mapped to over here, and then we're coming back like that. Okay, so now that's how the transformation works. We'll look at doing an integral with this in a couple videos after we look at the Jacobian. Peace.